In this lesson we're going to have a look at how a nuclear reactor works, and to do that we're going to use this simplified schematic diagram here. So we've got the reactor core here on the left, and let's supposing that we're starting from scratch, so what we need to initiate our nuclear reaction, as you saw in the previous lesson, is a supply of neutrons. So if we're actually starting this reaction from scratch, this initial supply is known as the startup source, and a typical candidate for the supply of these neutrons is californium. Okay, so these neutrons will then interact with the nuclei in the uranium rods. So these are the uranium rods. Okay, so remember we're using uranium-235. And in order for fission to take place, in order for this nuclear reaction to take place, then these neutrons need to be slowed down. So to slow down the neutrons, we're using a graphite moderator. And so these blocks marked in grey are the graphite moderators, and they will help to slow down the neutrons so that they can get absorbed by the uranium nuclei in these uranium rods here. Now, as you learnt in the previous lesson, one of the big dangers with this type of energy source is that we are initiating a chain reaction. So once the fission process takes place in these uranium rods, then more neutrons will be liberated, which will then interact with more uranium nuclei, which will go on and on and on, releasing more and more energy. And if you're not careful, your chain reaction could get out of control and you get a nuclear explosion. So what is very important in this energy production system is that we're able to control that chain reaction. And the way this happens is using these boron control rods. Okay, these are the rods marked in purple. Okay, so these are boron control rods, and these can be lowered into the reactor core to reduce the number of neutrons present and so slow down the nuclear reaction that's taking place. So you can control the nuclear reaction using these boron rods. Okay, so basically you've got a nuclear fission reaction taking place. The uranium nuclei are splitting, releasing neutrons. These neutrons are slowed down by the graphite moderators and can be completely absorbed by the boron control rods, so that the nuclear fission reaction doesn't get out of control. What we want from this nuclear reaction is energy. Okay, that's the whole reason why we've got the nuclear reactor. Okay, and this energy is going to be used to produce electricity. How does that happen? Well, this reactor makes use of two circuits, if you like. First of all, we've got a pump which is driving carbon dioxide into the reactor. The gas is then heated up by heat from the nuclear reaction. That then passes into a heat exchanger. So we've got hot carbon dioxide here. Okay, and in the heat exchanger, heat from the carbon dioxide is then transferred to water. So you've got cold water flowing around this system, which is being transformed into steam in the heat exchanger, which will then power a turbine. And the turbine, as in a conventional coal or oil or gas-fired power station, will then drive an alternator which will produce electricity.